In this lecture, we will be talking about Chapter 1, Evolutionary Theory and Natural Selection. Specifically, we will discuss basic definitions that you need to know, the history of evolutionary theory, Darwin's observations and conclusions, and then briefly discuss the concept of artificial selection. So our first question is, what is evolution? So evolution is the change in inherited characteristics of biological populations over successive generations. Basically, this is the change in genetic structure of a population. This raises the question, what is evolution not? Evolution does not constantly strive towards perfection, despite what a lot of people might think. So some people think evolution is progressing humans towards perfection. But rather, evolution is random, and basically the traits that exist were just better adapted to the environment than others. Another key term for you to know is adaptation. This is a feature of an organism created by the process of natural selection, and an adaptive trait is a trait that is inherited that increases the probability of survival or reproduction in the environment. An adaptive trait in one population may be maladaptive in another, and an example of that is skin color. So lighter skin tones become more maladaptive when you get closer to the equator because it increases the risk of skin cancer. Okay, next let's briefly talk about the evolution or the history of evolutionary thought. So some people think that Charles Darwin was the very first person to come up with the concept of evolution, but this is simply not true. However, for a very long time, a lot of people thought that species were fixed and unchanging. So for example, many of you probably remember Aristotle and his great chain of being. These categories, which are in the image on the slide, were fixed and unchangeable, with God at the very top and plants and minerals at the very bottom. This concept is also derived by Plato. It's a hierarchical structure of all matter in life believed to have been decreed by God, and the elements ascend toward perfection, which is probably how a lot of the misconceptions about evolution, striving towards perfection, have emerged. But later on, Linnaeus in the 1700s, he created modern taxonomy and what we know as binomial nomenclature. So that is, for example, how we're described as Homo sapiens. Even though this was more scientific, he also believed in species being fixed and unchanging. And actually, this mentality persisted in education into the 19th century. However, with time, researchers started to look at evolution through a different type of lens, or started to think of the concept of evolution. So James Hutton is one of the first people that kind of paved the way for Darwin. He was the father of modern geology, and he believed he coined this concept called uniformitarianism or gradualism. And this explains features of the Earth's crust by means of natural processes over a geological time. So, in this sense, he thought that the Earth needed to be ancient and, discussed the possibility that it changed slowly over time. He definitely influenced Darwin's ideas with the concept of gradualism because the prior belief was that species were fixed. Next, we have Jean-Baptiste Lamarck, and he thought of evolution as something that moved from being simple to complex. He coined the term evolution, which means change over time. He said that evolution was a force that caused organisms to go from simple to complex. And he said that it was a force that allowed animals to adapt to their local environments and differentiated them from each other. Although he was not the first thinker to advocate organic evolution, he was the first to develop a truly coherent evolutionary theory. He had some ideas that were wrong, so he thought that evolution involved moving up a ladder of progress, which that is simply not true. He also thought that traits that were acquired within an individual's life were passed to the next generation, meaning that if you became strong, that you would automatically pass this to your offspring. Next, we have Thomas Malthus. Thomas Malthus studied population dynamics, and he said that populations struggle when resources are limited. In other words, when the number of the population exceeds the number of resources that are available, populations will struggle. George Cuvier was another influencer of Darwin's thoughts. He said he was a paleontologist and said that fossils could be used to assess time for life on Earth, and also came up with the concept of catastrophism, which is when animals go extinct when environmental pressures are too great, which can lead to mass extinctions. Finally, Darwin's grandfather was a huge influencer of Darwin. He was a proponent of the theory that species change over time. However, he didn't know how or why species changed over time. Then we have Alfred Russel Wallace. He also came up with the theory of natural selection independent of Darwin, but we'll talk about him more in just a moment. Because next, I want to talk about Charles Lyell. He was a geologist and said that the Earth is changing and that it changes gradually and follows informed or uniformed predictable processes. So all of these people helped influence Darwin's thinking. So by the time Darwin became interested in the concept of evolution, this did not happen automatically. He was actually originally a medical student and had this long-term interest in natural history. He ended up dropping out of med school and pursued studies associated with evolution and geology. Then his father tried to send him to Christ College in Cambridge to become an Anglican parson, but he kept following his passions focused on naturalism, geology, and entomology. Then he was invited to be a companion on the voyage of the HMS Beagle, which was a 5-year voyage. And he ended up taking a lot of notes on marine invertebrates. He had major fossil finds and read a lot of works by Lyell. And during this trip is when he went to the Galapagos Islands, which is the very famous discovery of the finches, which is discussed in the first chapter of your book. So Darwin suffered from a lot of poor health, but somehow he managed to publish 3 geological books within 6 years, and in 1858 began writing on the origin of species. However, Alfred Russel Wallace also was writing and thinking about the concept of natural selection. And once Darwin realized this, he quickly wrote a short paper explaining natural selection so that Wallace would not scoop him. He later published On the Origin of Species, but he nearly died due to a sickness that's a little bit unknown and also had to do with a lot of anxiety because he was going against his family by talking about evolution. Basically, Darwin's main contribution was the mechanism. This means the how. How does evolution occur? And the how is actually the concept of natural selection. So how does natural selection work? Well, first of all, there is a struggle for existence. And Darwin also postulated that there's variation in features related to survival and reproduction, and that this variation is passed from generation to generation. He said these 3 postulates make evolution by means of natural selection inevitable. Proof for his theory on adaptation by natural selection was actually given by a lot of different sources, but one is the Galapagos Islands in Ecuador, which is where Darwin visited during his trip on the HMS Beagle. So Peter and Rosemary Grant conducted this research with finches, and they were able to observe the evolution of beak size over the course of a couple generations due to both drought and heavy rains. This example is in your book, and I highly recommend going back and reviewing it a few times so you have a really good understanding of what happened. I'll also post a video on this as well. But importantly, what I want you to also keep in mind is that evolution and natural selection operates on the level of the individual, not for the good of the species. So one idea of this is that if you think about it, in a lot of primate species, you'll see a female who has a high amount of offspring, maybe 10, but only 3 of them survive. If natural selection was operating on the level of the species, it would be a waste of resources to have that many offspring if you know that not all of them are going to survive. Rather, natural selection is operating on the level of the individual because the increase in the number of individuals may increase the likelihood that some will survive, which is why one female will have so many offspring. So anyway, that's why natural selection operates on the level of the individual, not the good of the species. Other evidence for natural selection is through the process of artificial selection, where humans have domesticated and selectively bred plants and animals. We see rapid changes in very few generations. And this photo here is of my little puppy. When he was a puppy, he's not so much a puppy anymore. So anyway, these questions, or Darwin's contribution was pretty grand. However, he couldn't really explain a few things, which are explained in the next chapter. For instance, he had this concept of blending inheritance, which you can read more about in your book. But it kind of begged to this question, how is variation in a population maintained if natural selection eliminates it through the process of blending inheritance? And where do novel forms come from if not already present in the original population? So we'll explore some of these questions in the next chapter.